Hi, Keri. I saw your email with a couple of different questions, so I'm going to go through them for you here. First one, let's start with the Module 17 quiz. Number 3, because it's the kind of quickest I can run through. So you have, given the problem is the number of faces and the number of vertices. So let's pretend we start with the number of faces being 14 and the number of vertices being, let's go with 16, okay? And they're asking for how many edges does this three-dimensional solid have? And what you're going to, which is correct, is to go to your Euler's formula. So Euler says that your number of faces plus the number of vertices is equal to the number of edges plus 2, right? If you add 2 to the edges, then that's the same as the faces plus the vertices. So what you want to go ahead and do is go ahead and plug your numbers in. So this would be 14 plus 16 equals E plus 2. 14 and 16 together are 30. So 30 is E plus 2. Now subtract your 2 from both sides, and you end up with 28 edges. I think what you were trying to do was to subtract 2 from that, or add 2 to the 30 as opposed to subtracting 2 from the 30. But it all comes from plugging your values in, okay? Let me quickly take a peek at what else you had asked about. Okay, so the next was your question about Module 16 and the quiz there. It says a rectangle is sometimes a rhombus. I selected never and got it wrong. Okay, so you have a rectangle is blank, a rhombus. And these questions can be a little bit challenging for us, particularly because we have in our mind images of what these things are. So you're thinking, oh, well, this is a rectangle, right? And a rhombus looks like this, right? So those things are not going to be the same, but that's not necessarily true. What we want to do is we want to think about the names of these as a set of criteria. So to be a rectangle, you have to have 4 equal angles, right? And because it has to add to 360, these all have to be 90 degrees. So you have to have 4 90-degree angles to be a rectangle. As long as you do, then you can call yourself a rectangle, right? To be a rhombus, you have to have 4 equal sides. Okay. So the question is, if you said never, that means that I cannot draw something that is both a rectangle and a rhombus, meaning it has 4 90-degree angles and it has 4 equal sides, but I can. So what you want to do here is you want to think about, if these are the 2 sets of criteria, can you draw something that is both, right? That meets both sets of criteria. So I need to draw something that has 4 equal angles, so 90-degree angles, and all equal sides. Well, I can if I draw a square. So there is a shape that has 4 equal angles and 4 equal sides. So that means I can call it a rectangle. I can call it a rhombus. Its best name is a square, but it also meets those other criteria, right? It's like saying you as a person, like I'm a mom and I'm a CrossFitter, but and so I fit into all those criteria, even though I don't look like what you think of as a CrossFitter, right? So that's kind of what you want to think of. Then you want to think about, we need one that is not, okay? So that means it's got to be a rectangle, okay? Because you're saying a rectangle is. And so I want to say I can do a rectangle that is a rhombus. That's the square that I drew. And then can I draw a rectangle that is not a rhombus? Sure, I can do that. If I draw what's more traditional rectangle, it would look like this. And that's not a rhombus because it doesn't have all equal sides. And because I can do both of those things, the answer here is sometimes. Okay. If I couldn't draw the both one, then my answer would be negative, never, right? Because I can't do both things at the same time. If I can do both, but not the is not one, then the answer is always, because I can't draw something that's not a rhombus. So that must means it's always a rhombus, okay? So that's what you want to think about when you're doing your sometimes, always, never questions. Identify what the criteria is that makes that shape special. And then you're going to say, can I draw something that has both? And then can I draw something that is the first thing, but not the second thing? Okay. Okay, so draw a rectangle that's not a rhombus. So hopefully that'll help you with some of those. And then the last set, you're working on the homework. So let me pull that up. Give me a second. You're working on 17.2. I don't have this copied and ready to go yet. Okay, 17.2. Letter 1, D, E, and F. Okay. Okay, so we're referencing all of our A through K values. So you're talking about number 1. This is 17.2, number 1, letter D. Letter D says none of the triangular faces is equilateral. Okay, so you're saying if it's got a triangle, then that triangle is not equilateral. And let me pull up my shapes here. Add an image of that. So let's take a quick peek. Here they are. Okay, so these are our shapes. A, we said, was a tetrahedron. So that one, oops, sorry. Nope. This is the picture. There we go. There we go. So that one definitely has equilateral triangles. B doesn't have triangles. C does. Now we can't see them in this angle, but on the ends there, and those do appear to be equilateral as well. But starting with D, that one has triangles, and notice that the apex is not over the center. So you're going to get triangles that are not equilateral, meaning all equal sides. Okay, so D is definitely going to be on our list. E and F don't have triangular faces. G, those appear to be not equilateral because the bottom side is not as long as the top. H is so G would be on our list. So far D and G. And then H is your octahedron. So those are all equilateral. This one, I, definitely has triangles that are not equilateral. So that one would be on our list, sort D, G, and I. J, those triangles are also shorter at the bottom than they are in the top. And so that one would count as well. So I'm going to say D, G, I, and J. So D, G, I, and J. Now, if you included things that have no triangles, that's also fine because that would also meet the criteria that none of the triangular faces is equilateral. Okay. But I'm not going to list them here because they just don't have triangles. Okay, let's talk about E. Two faces are parallel and congruent, but the shape is not a prism. Okay, so you want two things that look like bases, but they don't have parallelograms between them. So if I go back to my picture, okay, let's see. So anything that's a pyramid is already off the table. So B, that one is a prism, and I think we have that on our list. C is a prism, D is a pyramid, E is a prism, F is a prism, G is a prism. H has no parallel faces, right? There's nothing that you can match up. I also has no parallel faces, but J and K do. So notice that J and K, J has a square on each side, and then it has triangles around. So it does have two faces that are parallel and congruent, but its sides are not rectangles, so it doesn't count as a prism. So J would be on my list. Same thing here for K. Those two rectangles are actually parallel, and they're the same size, so they're congruent, but what's between them is trapezoids, and that's not parallelograms, so this does not count as a prism. So J and K are going to be the ones that we list here. So J and K for that one. And then F. More than one face is an isosceles trapezoid region. Okay, so the only one, if we look, that has trapezoids here. Now, we are not counting trapezoids that are also parallelograms. So this is something that's a trapezoid only and not a parallelogram. The only thing that has trapezoids is K. Okay, it has 4 of them, so it has more than one. And they do happen to be isosceles. So the only thing here would be K. H. No edges are parallel. Okay. So first of all, anything that has a parallelogram is going to have edges that are parallel. So anything that has a parallelogram is already off the table. Anything that has a square or a rectangle also is going to be off the table. So let's take a quick peek. So A has nothing that is parallel, right? None of those lines are parallel, so A would count. B has parallelograms, C has rectangles, D has a square, E and F have squares and rectangles, so none of those are in. So far it's only A. Next we look at G, and G also has nothing that is parallel, so A and G so far. H, those ones around the middle on opposite sides are actually parallel. They kind of form a square, even though they're not in the same face. Okay, so that one doesn't count. So I'm still at A and G. I has a square on the bottom, and you can see J and K also have squares and rectangles. So the only ones that fit this are going to be A and G. Okay. All right, number 5. Test the relationship you found in activities 5 and 6 using shapes H, J, and K and any other polyhedron that you have that is neither a pyramid nor a prism. Okay, so all I really want you to do is H, J, and K here. So for part A, you're just going to test that. So without going into too much detail here, you're going to try to determine how many faces. So H, we actually already did, right? That's a dodecahedron. So there are 8 faces to this. So this is for H. There are 6 vertices and there are 12 edges. And if you check, 8 plus 6 equals 12 plus 2 works, okay? What did they say? J and K. For J, if I take a look at the picture, let's see. There are 2 bases, the 2 squares, and then there are 4 triangles that come off of each side of each of the bases. So there are 8 triangles, and that means there are 10 faces. All right, edges could be a little tricky based on this vantage point. Let's see, we've got 4 edges. So, okay, let's do vertices first. You have the 4 vertices here, and you have the 4 vertices on the bottom, and then the lines just connect those up in various ways. So that's all we have. We're going to have 8. Okay, now our edges, we have 4 on the bottom, 4 on the top to make the 2 squares. And then we are going to have, we have 8 triangles. So 2 sides of each triangle would be 16, except they share them. So that would be 8. So they're going to be 8 more. That gives us a total of 16 edges. And you can check that 10 plus 8 is 16 plus 2. And then do the same for K. And then when you go into B, C, and D, you want to do something similar. So for part B, suppose a polyhedron has 10 vertices and 15 edges. How many faces does it have? Okay, so you're going to do the same thing here, and you're going to set up your faces plus vertices equals edges plus 2, and plug it in and solve for F. Okay, so this is a little bit of kind of algebra. Letter C, suppose another polyhedron has 20 faces and 30 edges. How many vertices? Same kind of thing. And can the number of vertices and the number of faces and the number of edges all be odd numbers? So this one's a little bit trickier, so I'll go through this one for you. We have faces plus edges equals vertices plus 2. And they're saying, can all of these be odd? So you want an odd number plus an odd number equals an odd number plus 2, okay? Now, take any two odd numbers that you like, 7 and 3, add them together. You get 10. It's not odd. So when you add 2 odd numbers together, they turn out to be even. When you take an odd number and you add 2, 5 plus 2 is 7, 7 plus 2 is 9, you get an odd number. And so that means you would have to have an even number that's equal to an odd number, and that's just not true unless there's 0. So you cannot have all 3 being odd for that very reason. So this problem purely uses your Euler's